Your phone connects before you even notice. You walk into a cafe, your screen wakes up. A tiny symbol appears in the corner. And just like that, your device has made a decision. A quiet one, a fast one, a decision about who it trusts. Not who you trust, who it trusts. That network you just joined might belong to the cafe, or the shop next door, or a router taped under a table 5 meters away by someone who really likes other people's passwords. Your device doesn't ask you any serious questions. It doesn't explain its reasoning. It doesn't show you the trade-offs. It just nods politely and shakes hands with something invisible. Every laptop, every phone, every tablet is constantly negotiating with the air around it, ranking signals, remembering past relationships, making bets about speed, safety, and convenience in a few milliseconds, all while pretending this is just Wi-Fi working as normal. Most of the time, nothing bad happens, which is exactly why this system has survived. But when it fails quietly. No alarms, no warnings, just data drifting to the wrong place. So the real question isn't whether your device connects, like it's how it decides who deserves to be trusted in the first place. Early computers didn't roam. They stayed put. If you wanted a network, you plugged a cable into a wall and trusted whatever was on the other end by default. Trust wasn't a decision. It was a physical fact. The cable was either there or it wasn't. Then Wi-Fi happened, and suddenly the air filled up. Today, your phone can see dozens of networks at any moment. Apartments stacked on apartments, offices leaking signals into cafes, personal hotspots flickering on and off like fireflies. Each one shouting the same thing into the void: connect to me. Your device has no map. No context, no idea who owns what. All it gets is a name, a signal strength, and a few technical promises scribbled into radio waves. So engineers had to teach machines how to choose. At first, the rules were simple. Stronger signal wins. Known name wins. Networks you've used before go to the front of the line. It's the digital version of recognizing a familiar face in a crowd and assuming everything will be fine. That worked, until it didn't. Because network names are not unique. Free Wi-Fi isn't a brand. Airport Wi-Fi isn't verified. Your device doesn't know whether the network called Coffee Shop Guest is the same one you trusted last week, or a perfect imitation broadcasting from a backpack. And yet, the system keeps pretending it does. Behind the scenes, your device keeps a little diary, a list of past connections, security settings, encryption types, whether a network asked for a password or smiled and waved you through. When it sees a familiar name again, it assumes continuity. Same name, same trust. That assumption saves time. It saves battery. It saves you from tapping buttons. It also opens the door to impersonation. The irony is that this entire system was optimized for convenience long before threat models caught up. Wi-Fi was designed to feel invisible, automatic, effortless. You're not supposed to think about it. And that design goal shaped every decision that followed. By the time attackers realized they could exploit that trust, the behavior was already baked into billions of devices. So now, every time you open your laptop in public, a silent auction begins. Networks compete. Your device scores them. Past familiarity gets bonus points. Strong signals get priority. Security features help, but they're just one column in a much larger spreadsheet. And you never see the spreadsheet. You just see the little symbol light up and assume the choice was obvious. Because your device isn't actually asking which network is safest, it's asking which network will work without annoying the human. That difference matters. Every time your phone scans the air, it builds a short list. Networks it remembers. Networks it can see clearly. Networks that don't demand effort. Then it starts eliminating friction. Password prompts are friction. Login pages are friction. Failed connections are friction. The fastest path to internet works usually wins. This is why devices love familiar names. It's why they'll cling to a weak, unstable signal just because they've met before. It's why they sometimes ignore a perfectly secure network across the room in favor of something louder and lazier. And this is where things get exploited. An attacker doesn't need to break encryption. They just need to be more convenient than the real network. Match the name, crank the signal, copy the security settings closely enough that your device shrugs and says, good enough. From the device's perspective, this isn't reckless. It's consistent. The rules are being followed. The math checks out. Because the math is not moral, it's statistical. Your device assigns weights. Signal strength might be worth this much, past usage that much, encryption type a bit more, response time, stability, battery cost, all of it collapses into a score. The highest score wins the connection. No single factor is decisive. Safety is just one vote in a crowded room. The uncomfortable part is how often this works in the attacker's favor. Public places are noisy. Signals bounce. Legitimate routers are overloaded. Meanwhile, a fake access point has one job and unlimited patience. It's calm, clean, powerful, friendly, and your device prefers friendly. Even worse, once that connection is made, trust compounds. Your device updates its diary. This worked last time. Future connections get faster. Automatic. silent. The illusion of safety grows stronger with every successful use. Nothing looks broken, nothing feels suspicious, until you realize how much power that first decision had. Because the moment your traffic flows through the wrong network, the rules change. Encryption might protect some things, but not all things. Metadata leaks, requests reveal patterns, updates get intercepted, small compromises stack into larger ones, and the device never tells you it took a risk. From its point of view, it didn't. It just optimized for the outcome it was designed to care about most: you staying connected. Because at some point, engineers had to choose what failure looks like: a moment of danger or a moment of inconvenience. And over again, the system chose inconvenience as the greater sin. Imagine the alternative. Every time you open your laptop, it pauses, asks questions, demands proof, warns you that 3 networks are suspicious and 2 are lying and 1 is probably fine but not guaranteed. You'd hate it. You'd turn it off. You'd look for the checkbox that says, just connect. So the system learned to be confident instead of correct. Modern devices don't verify networks the way humans verify people. There's no ID check, no reputation system shared across the world, no universal memory of bad actors. Each device lives in its own bubble of experience. If a network hasn't betrayed it personally, trust resets every morning. That's the hidden mechanism. Trust is local, temporary, forgetful. Even the strongest security standards mostly protect the contents of your data, not the context. They assume the network might be hostile but still allow it to exist in the middle. That assumption made the internet scale. It also normalized the idea that being connected is more important than being certain. There's a quiet irony here. The more advanced our devices become, the more they hide uncertainty from us. Signal bars look clean. Icons stay simple. Language gets reassuring. Connected. Secure. As if those are absolute states, not probabilities. Underneath, everything is probabilistic. Your device is constantly guessing, updating beliefs, rewriting its own understanding of the environment based on incomplete information. It's not choosing truth. It's choosing the least annoying version of reality. And this is where hype collapses. We're told modern security is airtight, that encryption solved it, that the scary parts are handled. But encryption doesn't choose networks. Algorithms do. And algorithms inherit priorities from the people who design them. Those priorities were shaped by a world that wanted Wi-Fi to feel like electricity. Always there, always on, never questioned. So the real risk isn't a hacker in a hoodie, it's complacency encoded at scale. Billions of small decisions optimized for comfort, repeated billions of times a day. Most of the time, nothing happens. And that's exactly why this system persists. Because when failure is rare, invisible, and delayed, it looks like success until it isn't. This isn't really about Wi-Fi or cafes or even hackers. It's about delegation, about how much judgment we quietly hand over to machines because they're faster, calmer, and less annoying than we are. Your device doesn't understand trust the way you do. It doesn't feel risk. It doesn't imagine consequences. It works with history, probabilities, and incentives. And the incentive we gave it was clear: keep the human online. That bargain made sense when networks were scarce and threats were theoretical. It makes less sense now, when the air itself is crowded with competing intentions. But changing it would mean friction, more prompts, more hesitation, more moments where technology stops pretending to be magic. And people hate that. So instead, the system stays quiet. It smooths over uncertainty. It converts a messy, adversarial environment into a single reassuring word: connected. The irony is that the more invisible this process becomes, the more powerful it is. One automatic decision can shape everything that follows: what updates you receive, which services you trust, which data flows cleanly, and which takes a detour, all without your awareness. This doesn't mean your devices are broken, or malicious, or secretly working against you. They're doing exactly what we asked, optimizing for convenience at planetary scale. The uncomfortable question is whether that optimization still serves us, because trust, once automated, stops being questioned. And once it stops being questioned, it becomes infrastructure. Hard to see, harder to change. So the next time your phone connects instantly, without a word, consider what just happened. Not technically, philosophically. A choice was made on your behalf, based on math, based on history, based on priorities you never approved, but benefit from every day. And maybe that's fine. Or maybe, in a world where everything competes for your attention and your data, the most dangerous thing isn't a bad network. It's how easily we let machines decide who deserves our trust. Done watching. If you like this video, hit subscribe for more cool stuff.